Hi everyone, this video is going to be going over quiz 6 examples. If you've already completed quiz 6 and you're happy with your score, you don't need to retake the quiz, but if you do want to retake the quiz or use one of the other attempts that you're given, just complete the quiz as it is, and that'll reset it for you and you should be able to get another attempt at it. I'm going to be going over the quiz 6 examples that were originally in the notebook, but I'm also going to be going over some questions that I got by email. So if you want to see the questions that were asked to me by email that deal with, here, I'll scroll down to an example of that. So here's one of them, but basically these problems with the limit as h goes to 0, just use a algebra technique that you might not be familiar with, so we'll go ahead and work on that. But yeah, for now, I'll just start at the top here. This one asks which is the y is a function of x, so we can do, we have the graphs here, right? We've got, let's call them graph A and graph B. We can just do the vertical line test here and see that this one passes it, but this one does not. So we would say, in this case, y is not a function of x. Sorry, I'm using a new tablet here, so the lag on it's a little bad, so the handwriting is going to be not ideal, but so y is not a function of x, but something to notice for this one is that if we draw, instead if we asked is x a function of y, then y is our input and x is our output. So in that case, we'd be doing a horizontal line test. So just be aware if they're asking you, is y a function of x or is x a function of y? Because that'll change whether you do the vertical or horizontal line test. Here, I can solve this equation. So we're trying to figure out if x is a function of y or y is a function of x. If I solve this equation for y, I guess I'll start off here. So 4y is equal to negative 3x squared minus 2, that seems fine. And if I divide everything by 4, I've solved y as a function of x, so it's got to be one of these two, because y is a function of x. But if I try to solve this equation for x, I would get something like 3x squared is equal to negative 4y minus 2. And if I divide by 3, I get x squared is equal to negative 4 thirds y minus 2 thirds. And if I take that even one step further, this is the situation where we need to add that plus or minus to this side of the equation. So it turns out that x is not a function of y, because when we look at x as an output, we get two outputs. We get a plus and minus output. This next one, which of these is an equation of a line whose graph goes through the point negative 3, negative 4, and negative 7, 6. So first thing we want to do is identify the slope. Oh, excuse me. Okay, so the slope is going to be, let's use this as our second point, so negative 7 minus negative 4. and 6. Oh, sorry. Going a little too quick here. Okay, so 6 minus -4 divided by x2, which would be -7 minus -3. Okay, so this ends up being 6 plus 4 is 10, -7 plus 3 is -4, so that's going to be -5/2. So it's got to be either this one or this one or this one. These are all in this form of the y equals mx plus b, right, where b is the y-intercept, and the y-intercept occurs when x is equal to 0. So we are going to figure out what happens when we set x equal to 0 here. So we've got rewrite that same equation. If you have another method that you like to use here, once you've got the slope and a point, you can always use that to figure out b on here. I'm just going to show another method. So here's our slope. This is -5/2. I'm going to use this point here as my y1 and x1. So this is going to be minus -4 and minus -3. My y2 is going to be b, my y-intercept, and my x is going to be 0 in order to find that. So you get the same result if you would plug in the slope and this point x and y into here. Just another way to look at the same thing. Okay, so we get -5/2 is equal to b plus 4 divided by looks like +3. This is going to be -15/2 is equal to b plus 4. So we're going to subtract another 4 on top of that, so -8. So minus another 8/2 is going to be -23/2. That tells us that we're looking at this answer choice here. Function is represented by the graph below. A, B, and C in order of decreasing slopes. So this is going to be highest slope to lowest slope. That's what they mean by decreasing. So highest meaning most positive to most negative. Okay, let's look at the slopes here. We'll try to draw some tangent lines here. I would say that the order starting with the highest slope would be A, next up would be B, and then last would be C here, most negative. Here's an interesting question. So we're asking, this is our curve in the black, and then we want to know which of these is a line tangent to the black curve. Well, this line is a secant line, this line is a secant line, and this line is a secant line. So none of those are true. Another thing that they might ask is are any of these lines a derivative or represent the derivative of the slope at a particular point? So that would be, does this match the slope of the tangent line at a particular point? We could look at, for example, something like this and track to see whether or not that is equal to 0 at that point. But again, all they're asking is, are any of those lines tangent to the black curve? And none of them are. Which of the following choices best approximates the slope of the tangent line at 3.5? I'm going to make my best attempt to draw a tangent line at this point, how I would expect any of you to try and do the same thing. Here's 3.5, looks like it's looking about like that. Okay, I think that's a pretty good approximation here. Now that I've got this set up here, I can kind of look to see where my rise and run are falling on there. If they happen to fall on any grid lines, that's nice, but they don't have to. Pay attention to the scale here, right? It's not always going to be marked as exactly 1, 2, and 3, 1, 2, and 3. Might be marked by halves like it is here, or by whole numbers, but I would say this is pretty clearly 2, and this is going to be 1, 2, maybe looks like 2 1/4, right? Not quite way up to here. So rise over run, and it is positive here, right? Okay, so 1.125, that's looking like the closest. Which of the following is the slope of a line between the function this, between the points f of 3 and h plus 3, f of h plus 3 for any small number h? Okay, so here's your curve. The slope of the line between the points this and something else, what they're describing here is the tangent line here. So this is 3, right? However this curve looks, this is 3. This is 3 plus h. And we know from class that the thing that they're describing here, the slope of this line, m, is equal to the limit as h goes to 0. So we'll talk about setting that h equals 0 when we talk about the derivative, but we've got this. Okay. So first thing to figure out is what is f of 3. So I'm going to make a little list here. So f of 3, that's going to be equal to this set of directions here, where we figure out what that is when we plug 3 into that equation. So 9 times 3 squared plus 3 minus 5. So this is going to be 9 times 9, or 81, plus 3 minus 5. So that's going to be 79. f of 3 plus h. This is going to be a little bit more complicated, but that's going to look like 9 times 3 plus h squared plus 3 plus h minus 5. I'm going to expand this out here. So this is 9 times this is as though we multiplied 3 plus h times 3 plus h, so FOIL that out. Let's see, so again, we've got 81 plus 9 times 6 is 54h plus h squared plus 3 plus h, plus 9 h squared plus 3 plus h minus 5. 81 plus 3 minus 5, that gives us the same 79 here. Plus 9h squared plus h, so I'm going to go ahead and change this to 55h. And I believe that's everything. Okay, so working through this one, I've got m is going to be equal to 79 plus 55h, just plugging those in, 9h squared minus 79, all that divided by h. The 79s cancel out, so we are left with 55h plus 9h squared divided by h, which is equal to 55 plus 9h. That right there. Okay. This one here, I'm going to show you the solutions that I've got here, but basically this is just taking you through the algebra. This is just kind of manipulating the variables, but a couple things to keep in mind here is that you can split up fractions like this across the numerator, but you can't split them up across the denominator. But yeah, I think this lays out just the algebra that I'm using. I took a 2 divided by h out. I turned this 1 into h plus 1 divided by h plus 1 to give it the same. To give it the same denominator as this h plus 1 in here. But I think you should be able to follow along with this. I want to kind of get to some of the, it's my cat. I want to get to some of the other problems that have some less straightforward algebra that look like this one, because I think that's where a lot of people are getting stuck. Right? For this next one, which of the following lists all of the x values where the derivative does not exist on the curve below? So we looked at 3 different scenarios where the derivative does not exist. One of them is a situation like what we have at x equals 0. Where we've got unplugged my tablet there. Okay, so x equals 0. That gives us a discontinuity, so that's one spot where the derivative doesn't exist. The other thing we could possibly look for is a vertical tangent line. I don't see that anywhere here, but we do have a corner here. Right? So that sharp corner tells us that also f prime of 0 does not exist, and f prime of 2 also does not exist. Okay, this is the start of the newer section, or the the problems that were asked to me by email that I wanted to go over. I'll start with this one here. When we have something in a square root like this that we want to get rid of, because right now we can't plug h into this like we want to, what we want to do is multiply by a conjugate. So a conjugate works like this. It's just sort of a pair that you have with something else. So if I tell you x plus 3, the conjugate is x minus 3. Right? If I have square root of x plus 3 minus 17, then the conjugate is square root of x plus 3 plus 17. Right? So you're basically just changing this plus to a minus or this minus to a plus. That's what makes it a conjugate. And the nice thing about multiplying conjugates together, so for example, if I say square root of x plus 3 and square root of x minus 3, if I multiply those two things together, I just get this term squared minus this term squared. So I get x minus 9. Right? So that's going to come in handy here. We're going to figure out the conjugate of this thing. Multiply it by its conjugate. Hopefully get an easier term to work with, and then that'll be how we solve this one. I'm going to rewrite that equation, or at least this part of it. And I'm just going to notice that I've got a 2 and an h, so I can get rid of, or I can take this h term out, because I kind of like to just focus on this part here. Okay, so I want to multiply this by its conjugate. So this is a 1 right here because I brought this h out. I can't just multiply this by its conjugate without any additional stuff going on. So what I'm going to do is I'm going to multiply it by the conjugate up top here, and then what I'm doing is just multiplying this whole thing by 1, right? If I have everything up top here match everything down here, that's like multiplying by 1, but I get to multiply this top part by the conjugate. Okay. So again, multiplying by the conjugate, you get this term squared minus this term squared. So what that looks like is h plus 1, right? Square root of h plus 1 times square root of h plus 1 is just h plus 1, minus 1. And that's going to be divided by 1 times this term we came up with, which is square root of h plus 1 plus 1. 2 over h times, this is h, this is h plus 1 plus 1. And now we get to cancel out these h's. So we get 2 divided by square root of h plus 1 plus 1. When we set h equal to 0, we get 2 over 1 plus 1. Which is just 1. And we can see, let's see, which of these options here, 2 over square root of h plus 1 plus 1, that's going to be this one here. I'm going to do the same thing here, but this time my conjugate is going to be, so I'll rewrite this equation, 3 square root of 2 minus 3 square root of h plus 2. Divide by h. This time I'm going to pull a 3 over h out in front of all this. So what I'm left with is square root of 2 minus square root of h plus 2. Divided by 1. And I'm going to multiply that by its conjugate. So its conjugate is, I'm just going to change this minus here to a plus. Okay. 3 over h. Remember, this top part is going to be the first term, negative square root of 2 times negative square root of 2. So that is going to be positive 2. And then minus this term squared, so minus h plus 2, making sure we put parentheses around that because we are subtracting the whole thing. If you wanted to go ahead and FOIL out this whole, like all 4 of these terms here, you would get the same thing, but you probably saw this in an algebra class at some point. Okay. Down here, we've got negative square root of 2 plus square root of h plus 2. Two minus h plus 2 is going to be minus h. So we get 3 times this negative 1 that's left over. Let's see, does that match up with any of our solutions that we've got here? Not quite. So maybe we've got a, well, let's see, this is a, probably not this negative 1. Well, that doesn't make any sense. Let's see if this actually matches what we should be getting here. So this is a negative 3. Let me just double check to make sure I've done everything properly here. Oh, sorry, this should be positive. Yeah, I went ahead and added that negative for no reason there. So that won't affect this. Sorry about that. Okay. So yeah, we do have a negative 3 over And then this is just reordered. So we find that it's this is the value, and then if we set h equal to 0, then we're going to get -3 over square root of 2 plus square root of 0 plus 2, so square root of 2, or square root of 2 plus square root of 2 is just 2 square root of 2, which is going to be this one here. Okay, so I'm sorry about the little hiccup there, but yeah, just take whatever term you get out in front here, try to simplify it if you can, but the conjugate, that's what you want to multiply by. If you've got a negative here, change it to a plus. Okay, hopefully that helps you with quiz 6. Again, if you need to retake it, just send me, or sorry, if you need to retake it, just complete the quiz as it is, whatever attempt you're working on. You should have another attempt at quiz 6. All right, we'll see you on either Wednesday or Thursday.